Hello everyone. Thank you again for joining our LEED O&M exam prep program. Please use this time to adjust your speaker volume, screen resolution, and settings to better view this presentation. When watching this course on demand, you have the liberty to play, pause, and search for specific content within this module. This will help you when reviewing the content. Before we get started with Sustainable Sites, or SS, I hope you were able to read and familiarize yourself with the key terms related to this module. If you have not already, please do so later. We have loaded your on-demand account with key term presentations organized by LEED credits that explore all related key terms under the O&M rating system. If you have printed the handouts, you may use them to take notes on while we go through this module. If you've noticed, we've also uploaded study notes for each module. You may review them and print them if needed. The study notes include additional information such as related credits, reference standards, and tables. Here you can see the topics we will cover for each week. When watching this on demand, make sure you watch the 7 modules that represent the topics listed here. Here are the learning objectives for the Sustainable Sites module. By the end of this module, you will be able to identify the intent, requirements, and strategies for success within the Sustainable Sites credits, as well as identify how the SS requirements support a holistic integration of site with local and regional ecosystems, recognize synergies between multiple credits, and lastly, analyze credit calculations and see which credits qualify for exemplary performance. There will be a total of 9 questions on your LEED O&M exam from this module or knowledge domain, representing the topics you see on the screen. We will go through each of these topics and the related credits. Sustainable Sites is the second environmental category within the LEED rating system after LT. The SS category rewards decisions about the environment surrounding the building with credits that emphasize the vital relationships among buildings, ecosystems, and ecosystem services. It focuses on restoring project site elements, integrating the site with local and regional ecosystems, and preserving the biodiversity that natural systems rely on. Project teams that comply with the prerequisites and credits in the SS category use low-impact development methods that minimize construction pollution, reduce heat island effects and light pollution, and mimic natural water flow patterns to manage rainwater runoff. Here is a complete list of credits that fall under Sustainable Sites within the O&M rating system. These credits address the main goals that we discussed on the previous slide. As you can see from the table, there is 1 prerequisite and 7 credits under O&M. Not all credits apply for all project types or project adaptations. As you can see, credits 1 through 6 are adaptable for all project types, whereas credit 7, joint use of facilities, is only applicable to school projects. I have also included a column that will say whether the credit is eligible for exemplary performance. I would recommend memorizing these credits as well as the exemplary performance thresholds. We'll explain them all today. First, let's explore the prerequisite Site Management Policy. Once we are done learning how to implement the prerequisite, we will take a look at the related credits Site Management and Site Improvement Plan. This will help you understand the synergies between these credits. Site Management Policy is the prerequisite as applicable to all project adaptations listed here. Developing and implementing a site management policy early in the LEED process gives the team time to optimize projects, equipment, and strategies. Finally, a well-crafted site management policy enables a team to address unexpected complications. The intent of this prerequisite is listed here on the slide. Good exterior maintenance practices can significantly affect a project site and its surroundings. Site management practices not only protect soil, water, and air resources, but also yield economic benefits. For example, proactive maintenance and monitoring may detect irrigation system leaks before the wasted water causes unnecessary expense. Realization of such benefits begin with a clear, thorough site management policy. Project teams should investigate the best practices, assess the current practices, and establish measurable goals and objectives. A good site management policy will function as a performance baseline against which a project team can objectively measure shortcomings and achievements. It also can establish a foundation for long-term site management success. As I mentioned in Module 1, the LEED O&M rating system includes establishment and performance requirements for credits. For this prerequisite, we only have establishment requirements. For the related credit, site management, there are performance requirements as well. The prerequisite requires projects to create and implement a site management policy that employs the best management practices to reduce harmful chemical use, energy waste, water waste, air pollution, solid waste, and/or chemical runoff for all of the operational elements in the building and on the grounds as you see on the screen. If you think about it, these items can be categorized into 3 main focus areas or avenues to green with an existing building project: equipment, materials used for maintenance, and the maintenance method or practice itself. Now let's look at how to implement this prereq. We've listed the steps here. As you can see, we've included icons that denote intent, requirements, implementation, and other important points regarding the credit. This will help you associate what you learn with how it relates to a credit and the project. The first step to implement this prereq is to research and review the best management practices for each operational element specified in the prerequisite requirements that I showed on the previous screen. The next is to gather information on current site management practices and identify goals and objectives for the project. Owners, property managers, site and ground managers, and relevant vendors can also help identify goals and opportunities for improving the site management. The team should include at least one goal for each operational element applicable to this site. Here are some of the best management practices that we have listed for operational elements, such as using low-emission maintenance equipment, determining treated and untreated areas for snow and ice, considering salt-free or environmentally preferred de-icers, or using green cleaning products. We also have specifying the ongoing maintenance of stormwater systems if present, developing erosion and sedimentation control for ongoing operations and for construction activity, and organic waste management and fertilizer use. Another operational element of this prereq is irrigation management. Projects should monitor irrigation systems manually or with automated systems at least every 2 weeks or 14 days during the operating season for appropriate water usage, system times, leaks, or breaks. This is a possible question. Listed here are some more of the best management practices for operational elements in the site management policy. This table is also included in your Module 3 study notes. The next step is to establish performance metrics for each operational element to facilitate performance tracking and evaluation. Performance metrics allow teams to gauge ongoing progress. Team members who will be responsible for gathering, tracking, and evaluating performance information should be identified. The team should then write the management policy to include the scope, goals, roles and responsibilities, strategies, and performance measure and quality assurance. Once the policy is created, the next step is to roll out the new management policy and clearly communicate any new programs, procedures, or activities to the responsible parties. The project team should work with vendors to determine which of the best practices can be adopted immediately, which require phased implementation, and which may be only seasonal. Though it is not a requirement, conducting a kickoff meeting a few weeks before the start of the performance period is a good idea so that all parties understand their roles and responsibilities. Project teams may begin gathering performance data or other documentation on adhering to the site management policy. Note that performance data is not required for SS Prerequisite Site Management Policy, but is required for SS Credit Site Management, which we will look at next. LEED submittal or documentation requirements for the prereq are listed here. Note that projects should provide justification for operational elements not included in the policy. This is a possible question. With respect to project adaptations, school projects should include athletic or playing fields within the LEED project boundary in order to meet the Prereq requirements. This is another possible question. There are no reference standards for this Prereq. Remember to download and print the credit summary and reference standard documents from your on-demand portal. They are good reference guides and memorization tools. Related credits or credit synergies are important to understand for your exam as well as project implementation. We've included a list of them in your additional handouts for each module. In order to better understand these relationships, I recommend revisiting the related credit slide after you've completed this module, and again after finishing all other modules as well. Some credits are linked and related to multiple credits across multiple credit categories. The Site Management Policy is the primary tool for establishing the best practice maintenance procedures that support achievement of SS credits, Site Management, and Site Improvement Plan. The Site Management Policy can also support on-site habitat and biodiversity through maintenance of the site's native or adapted vegetation, which positively affects the SS credit Site Development, Protect or Restore Habitat. We will take a look at these credits next. The development of the Site Management Policy should be coordinated with the irrigation system pursued under the Water Efficiency Credit, Outdoor Water Use Reduction. Alright, let's take a look at the related credit, Site Management. The intent is the same as the Prereq. This credit is worth 1 point for all of the 6 project adaptations under the O&M rating system. Notice the main difference is the Prereq requires the project to have a site management policy, and the credit requires the team to implement a site management plan. Remember, policy for the Prereq and plan for the credit. The requirements for the Site Management Plan credit are performance-based. As I mentioned earlier, the Prerequisite Site Management Policy focuses on setting up and implementing the policy. The credit, however, focuses on implementing the plan within the performance period. The key difference is that the performance data is not required for SS Prerequisite Site Management Policy, but is required for SS Credit Site Management. In order to earn the Site Management credit, projects should first perform site management activities to meet the performance criteria set up in the Site Management Policy that was developed as a part of the Prereq. The goals and objectives identified by the team and established in the SS Prerequisite Site Management Policy serve as the foundation of a set of the best management practices that, when met or exceeded, can provide excellent results for the property and the grounds. Once the initial performance criteria are met, projects have 3 options to choose from to earn 1 point. Let's take a look at implementation. Step 1 is to align goals in the Site Management Policy with minimum thresholds for credit compliance. Once the policy is updated, implement the policy for the elements identified in the credit. Projects should implement and track activities to verify that the performance criteria are met. Listed here are the performance thresholds for the operational elements. A good way to remember these is to categorize them into 3 main focus areas or avenues: materials, practices or methods, and equipment. If you remember, we gave a similar list under the Prereq. Projects should demonstrate the performance criteria listed here for the following: de-icers, either do not use calcium chloride or reduce the treatment area to 50%. Soil erosion control, air pollution, organic waste management, and fertilizer application, irrigation management, and storing materials. All of these operational elements were discussed under the Prerequisite as well. However, the performance thresholds were not present for any of these except for irrigation management. They appear to be the same for both the Prereq and the credit. Table 1 lists the operational elements addressed in the SS Prerequisite Site Management Policy that must also be tracked during the performance period for this credit. This table is also included in your Module 3 study notes. You are not required to memorize the list, but I would advise you to understand and learn the strategies. LEED project teams are expected to demonstrate full performance for each element listed. Partial or incremental adoption is not permitted. A major component of site management is the type of maintenance equipment used. Gasoline-powered equipment contributes to greenhouse gas emissions and can cause noise and air pollution, reducing occupants' health and comfort. Therefore, the next step under the credit is to inventory the current equipment used. Review the site's current conditions and maintenance equipment. Inventory all equipment used, including any equipment brought to the site by contractors. Identify which items, if any, are powered by gasoline. Project teams should select an option based on the results of the equipment inventory, site conditions, and the equipment that will be used during the performance period. Ensure that the goals and the performance metrics defined in the site management policy align with the option chosen. Option 1 is to limit turf to 25% or less of the vegetated area. Playgrounds and athletic fields in schools or parks are excluded from this option. Here is a simple calculation for option 1 to determine the area of vegetated turf. Remember, the goal is to limit the turf area to no more than 25% of the total vegetated area. Projects may include planter boxes and vegetated roof areas in the total vegetated area. This is a possible question. Project teams should exclude school or park playgrounds and athletic fields from the turf area. This is another possible question. Option 2 is to use all manual or electric-powered equipment in all site management operations. All equipment used on-site, including equipment owned by vendors and stored on-site, must be considered. This is another possible question. For the project to be eligible for option 2, no fossil fuel-powered equipment may be used on-site. Replacing equipment, such as gasoline-powered equipment, may be necessary for compliance. Option 3 is to show and maintain a 50% reduction in hydrocarbon and nitrogen oxide emissions and a 75% reduction in carbon monoxide emissions from baseline conditions. If pursuing this option, projects should use the Equipment Emissions Reduction Calculator provided by the USGBC to determine the annual baseline emissions and calculate the annual percentage reduction. To determine the baseline, project teams should gather information on all existing maintenance equipment used, such as equipment type, approximate number and duration of uses or events each year, and approximate usage hours. This is a possible question. Entering this information into the USGBC calculator will give the project the baseline hydrocarbon, nitrogen oxide, and carbon monoxide emissions. The team should then implement any necessary changes to reduce hydrocarbon and nitrogen oxide by 50% and carbon monoxide by 75% from the baseline. The greatest reduction in emissions can generally be achieved by replacing gasoline-powered equipment with manual strategies or electric-powered equipment. Another possible question. Reducing equipment runtime by limiting high-maintenance landscaping is another strategy. Table 4 is a sample entry from a log that tracks recommended maintenance by the equipment type. This credit is not eligible for exemplary performance. Throughout the exam prep sessions, you will see the thumbs up and thumbs down icons that denote whether a credit is eligible for exemplary performance. Project teams should collect documentation verifying activities during the performance period. They should use the performance metrics established in the site management policy as the basis for tracking and documenting all of the activities associated with site management. Vendors must supply the project team with the activity logs, purchasing records, and other information that confirms proper implementation of the policy and demonstrates compliance. Periodically spot check equipment used during the performance period to ensure that only vetted and approved equipment is actually being used on site. This is particularly important when equipment is used by a vendor and is stored on site, since vendors may also own and use non-compliant equipment at their other jobs. From an exam standpoint, documentation is important. Here are the documentation requirements for this credit. Rather than simply memorizing, I would recommend you analyze the requirements for each option, see how each option is different, and apply logic to remember them. Doing this will save you from having to simply memorize them. For instance, in this case, documentation requirements for all options are the same, except option 1 requires additional turf area calculations. Option 2 requires an inventory of current maintenance equipment, and Option 3, calculations pertaining to equipment emissions. By now, I'm sure it's clear why SS Prerequisite Site Management Policy is a related credit. Crafting a policy for the Prereq that clearly establishes strategies, guidelines, and goals will facilitate meeting the requirements of this credit. SS Credit Site Improvement Plan is also a related credit. We will take a look at this next. Soil testing completed for this credit can be used to inform the long-term objectives of the site improvement plan for the related credit. We've not looked at other listed related credits. I recommend revisiting these slides after you are done with each module. This will help you apply logic to understand, learn, and remember credits rather than simply trying to memorize them. These slides with additional information are included within the study notes. Let's move on to the next credit, Site Improvement Plan, which applies to all project types and is worth 1 point. The purpose of this credit is to outline how site improvement plans can help organize improvements over time. A good site improvement plan requires the team to engage qualified people, follow an established process, map out meaningful improvement initiatives, and work toward implementing identified no and low-cost measures. This is a possible question. As I noted in Module 1, the LEED O&M rating system includes establishment and performance requirements for credits. For this credit, there is an establishment as well as a performance requirement, as you can see here. While the establishment requirement is to develop a 5-year site improvement plan, the performance requirement includes 3 individual objectives. The first is to demonstrate that 5% is vegetated. The second is to implement no and low-cost measures. And the third is to develop a new plan and implement measures every 5 years. Remember, 5% and 5 years are key here. The first step to implement this credit is to assemble the team early in the project planning phase. The project owner should consider involving the team that is developing the site management plan under SS Prerequisite Site Management Policy and SS Credit Site Management. Industry professionals can assist the property team in gathering and analyzing site information to identify site improvements. The second step is to determine whether the project's current total vegetated area meets the required minimum percentage of vegetation, which is 5% of the site using the equation shown here. If the site meets the minimum threshold of vegetation, the team should include the protection of those vegetated areas in the site improvement plan. Otherwise, the team should include a requirement to increase the vegetated area as a part of the site improvement plan. Note that if pursuing this credit, the project should increase the vegetated area during the performance period, and the vegetation threshold must be met before the performance period ends. Also note that roof vegetation or green roofs and planters can be counted toward the vegetated threshold. This is a possible question. Step 3 is to perform site inventory by gathering information and developing an inventory of current site conditions. This includes creating a site map that identifies each area on the site and shows the currently vegetated areas. The next step is to use the inventory and the information gathered by the site team to define site improvement goals and objectives. This is when the team should address a variety of site concerns, including maintenance activities, watershed quality, soil quality, community congregation areas, plant types and vegetation palette, and exterior design strategies. The team should also be cognizant of the owner's project requirements, budget, and schedule, as well as unique opportunities and constraints to the site. The team must also establish monitoring activities for each site improvement element that will allow the team to accurately determine whether the objective is being achieved. The next step is to identify specific improvement measures, performance standards, and monitoring protocols. The team should address each topic area listed in the credit requirements: hydrology, vegetation, and soils. This is a possible question. And establish metrics to measure the progress made for each improvement, as well as protocols for monitoring their ongoing operation and condition. Note that each measure and its associated cost, benefits, and protocols must be summarized in the site improvement plan and categorized as either no-cost measure or a low-cost measure. Projects should implement all no and low-cost measures established in the improvement plan by the end of the performance period. In addition, projects must establish a 5-year implementation plan, including a timeline for all improvement measures. Remember, projects should review and update the site plan every 5 years to ensure continual improvement and ongoing monitoring. Listed here are a few examples of site improvement measures. If a measure is not implemented and there are no plans for future implementation, the project should provide justification for why the measure was rejected. You can also see an example of low-cost and capital cost items and schedule or timeline as documented by a project. Here is an example of a site improvement plan. We've included similar examples in the study notes. Using examples is a great way to understand, learn, and analyze a concept for your exam, as well as project implementation. Here are the documentation requirements. Note that the qualifications of all professional consultants is also a submittal. As you can see, there are 3 establishment requirements and 1 performance-related requirement. This credit is not eligible for exemplary performance. The next credit we will discuss is Site Development. Protect or restore habitat. All project types can earn up to 2 points under this credit. Restoration of soils, hydrology, and native plants improves the viability of ecological communities, helps to manage and filter rainwater, and can regenerate other ecosystem functions. The intent of this credit is to conserve existing natural areas and restore damaged areas to provide habitat and promote biodiversity. Projects have 2 options to meet the intent for this credit. To select the appropriate option for the project, the team should first determine whether to pursue on-site restoration, option 1, or off-site financial support, option 2. Option 1 is for projects with large contiguous parcels of land. The project team must restore a minimum area of 5,000 square feet or 465 square meters. For your exam prep, you do not need to memorize both measurement units. You only need to know one, as the answer choices will not include a correct value for one and an incorrect value for another. Project teams that pursue option 1 may also support conservation financially, option 2, but can earn credit for only one option. This is a possible question. Option 2 is appropriate for projects that do not have enough habitat area to meet the requirements for option 1 or do not wish to perform on-site restoration. Let's look at each option closely. Under option 1, on-site restoration, projects should restore 20%, including the building footprint, of all portions of the site with native or adapted plants. Native vegetation is any indigenous species that occurs in a particular region, ecosystem, or habitat without direct or indirect human action. Native species have evolved to the geography, hydrology, and climate of that region. Adapted plants are those that reliably grow well in a given habitat with minimal maintenance. We've included a whole list of key terms in a presentation titled LEED O&M Key Terms in your on-demand portal. The first step is to use this equation to determine the total site area that must have native or adapted vegetation. If the total area available for vegetation is less than the required minimum, the project is not eligible for option 1 and must pursue option 2 to earn this credit. If the currently vegetated area of the site exceeds the required area threshold and meets the credit requirements for native or adaptive vegetation, no additional restoration is necessary beyond the maintenance of the area, which must be tracked during the performance period. If the currently vegetated area of the site exceeds the required area threshold but does not meet the credit requirements for native or adaptive vegetation, the site area can be revegetated to meet the minimum vegetated area requirement. The project team should work with the site professionals to identify areas to be restored with native or adaptive vegetation, determine restoration strategies, and define the process and methods for restoration work. Areas that naturally do not contain vegetation can count toward restored area. For example, natural rock outcrops, ponds, and desert would all qualify under this credit. There is no need to vegetate areas that are not naturally vegetated. Project teams may need to submit documentation showing that the project site contains naturally unvegetated land or natural water bodies. This is a possible question. Lawns or turf grasses qualify as adaptive vegetation only if they are able to survive without mowing, fertilization, pesticides, or irrigation. Let's look at an example for option 1. The project is a small office building. To earn the credit, the project team is increasing the site's vegetated area. The site plan, in Figure 1, depicts an existing area of vegetation and the area that will be re-vegetated, and Table 1 shows how the project is documenting compliance. Now let's look at Option 2. Step 1 under Option 2 is to determine the amount of financial support. Using the equation you see on the screen, projects should establish the minimum financial support that must be dedicated to a qualifying land trust or conservation organization. Projects should provide financial support equivalent to at least 5 cents per square foot or 50 cents per square meter. Step 2 is to identify a qualifying partner organization. Project teams should work with an accredited land trust or conservation organization to identify a use for the contribution and establish an agreement with the organization detailing the use of the funding. Financial support must be provided to a nationally or locally recognized land trust or conservation organization within the same EPA Level 3 ecoregion or the project state, or within 100 miles of the project for projects outside of the U.S. For U.S. projects, the land trust must be accredited by the Land Trust Alliance. Examples of projects that would qualify for this credit include land acquisition or management of natural processes, native habitat restoration, watershed management, restoration or protection, and public urban green space restoration or revitalization. For projects outside of the U.S., conservation organizations should be within 100 miles or 160 kilometers of the project site. Project teams must identify the agency in their country that is responsible for land conservation issues. The U.S. federal agencies may be a good resource to identify counterparts in other countries. Groups that work internationally include NatureServe, Natural Heritage Program, Conservation International, and World Land Trust. The documentation requirements for this credit are straightforward and in line with the credit requirements. This credit is also eligible for exemplary performance under both options. For Option 1, projects should double the 20% restoration requirement and restore at least 40%. Under Option 2, projects should double the annual financial requirement by donating at least 10 cents per square foot or $1 per square meter. Let's move on to the next credit. Rainwater Management. This credit applies to all project types and is worth 3 points, except for schools, which can only earn 2 points. Conventional site development disrupts natural hydrological systems and watersheds through impervious area, soil compaction, loss of vegetation, and loss of natural drainage patterns. The cumulative effect of these changes is a disruption to the natural water balance and water flow. Typically, a conventional site's rainwater management technique is to address the runoff by piping and conveying it as quickly as possible into large, centralized facilities at the base of drainage areas. However, such a strategy, although intended to prevent flooding and promote efficient drainage, can harm watersheds. It increases the volume, temperature, peak flow, and duration of runoff, eroding streams and causing other ecological damage. The intent of this credit is to reduce the runoff volume and improve water quality by replicating the natural hydrology and water balance of the site, based on historical conditions and undeveloped ecosystems in the region. There are both establishment and performance-based requirements for the credit Rainwater Management. The establishment requirements include using low-impact development, or LID, practices to capture and treat water from 25% of the impervious surfaces for the 95th percentile storm event. In addition, projects should also establish and implement an annual inspection program of all rainwater management facilities to confirm continued performance. The performance requirements include documenting the annual inspections, including identification of areas of erosion, maintenance needs, and repairs. Projects should also perform necessary maintenance, repairs, or stabilization within 60 days of inspection. Now let's take a look at implementing this credit. The responsible parties for this credit include the landscape architect and the civil engineer. The project team should first obtain rainfall data for the project location for at least 10 years of historical rainfall data, or as much historical data as possible from all seasons to account for season variability. The project should include an explanation if it submits less than 10 years' worth of information on why additional historical data is not available. Using the historical rainfall data collected, the team should then determine the value for the 95th percentile rainfall events and calculate runoff volume. This is the precipitation amount that 95% of all rainfall events for the period of record do not exceed. The next step is to calculate runoff volume. The civil engineer or the responsible party has to identify the impervious areas from which the water will be treated according to the credit requirements. That is, the areas to be included in the 25% threshold. This is corresponding to the 95th percentile of rainfall events for those surfaces. This is the amount that the project will need to manage entirely on-site through green infrastructure and low-impact development techniques. Runoff volume depends on the specific post-developed site conditions of the project, such as amount of paving, permeability of different surfaces, roof area, and vegetated areas. Note that different methods can be used to calculate the runoff volume, such as the EPA stormwater calculator. The next step is to assess the current site conditions with a civil engineer, landscape architect, and other contractors or consultants as needed against the credit criteria. If the current management strategies provide adequate treatment, no further action is necessary to meet the credit requirements. If the current site conditions or strategies cannot capture and treat the required volume of runoff, or on-site strategies do not currently exist, the team should modify the site such that it can meet the credit requirements through strategies we will look at next. Green infrastructure, or GI, and low-impact development, or LID, rainwater management strategies and techniques improve upon a conventional approach by mimicking a site's natural hydrology. Green infrastructure is a soil and vegetation-based approach to wet weather management that is cost-effective, sustainable, and environmentally friendly. Green infrastructure management approaches and technologies infiltrate, evapotranspire, and capture and reuse stormwater to maintain or restore natural hydrologies. Low-impact development is an approach to manage rainwater runoff that emphasizes on-site natural features to protect water quality by replicating the natural land cover hydrologic regime of watersheds and addressing runoff close to its source. The team should work with rainwater professionals to identify and design the most appropriate green infrastructure and low-impact development measures for the site. This process may take several months to several years, depending on the complexity of the site conditions and the GI or LID measures selected. These measures must be in place by the end of the performance period to satisfy the credit requirements. In addition to mimicking natural hydrologic cycle processes, green infrastructure and low-impact development help to integrate the site with the surrounding watershed, are appropriate to local ecosystems and climates, and deliver such other benefits as water reuse, habitat creation, and species diversity. Examples include better site design principles such as minimizing land disturbance, preserving vegetation, and minimizing impervious cover, and design practices such as rain gardens, vegetated swales and buffers, permeable pavement, rainwater harvesting, and soil amendments. These are engineered practices that may require specialized design assistance. Project teams should consult the EPA's National Menu of Stormwater Best Practices and consider the following questions when selecting measures for the project. Which GI and LID measures will best mimic the natural site hydrology? How can multiple measures be used together in a treatment train approach to manage rainwater? What are the infiltration rates and capacities of the most practical measures, and how might the site's soil conditions affect their efficiency? How effective are the measures at removing contaminants from the rainwater runoff? Here is something to note for both the exam and project implementation. Impervious areas that are removed from the site and replaced with GI or LID measures, such as vegetation or pervious pavement, can contribute to meeting the credit requirements. In this case, the credit requirement is met if the redeveloped site's GI or LID measures can capture and treat the runoff from at least 25% of the baseline impervious area, that is, before site redevelopment. Alternatively, if at least 25% of the site impervious area is replaced by GI or LID measures, and those measures can fully contain and treat the rainwater for the 95th percentile of storm events, the credit requirement is met. The last step in implementing this credit is to develop and implement an annual inspection program of all rainwater management facilities, which is the performance requirement for this credit. Building operations teams should regularly evaluate rainwater measures to make sure they are performing properly by inspecting the site for changes in landscape contour, areas of erosion, plant health, and standing water for longer than 72 hours, or other problems, and identify maintenance and repair needs. Projects should perform necessary maintenance, repairs, or stabilization within 60 days of inspection. They should also maintain records of rainfall inspection activities and repairs. Listed here are the documentation requirements for the project. The credit is eligible for exemplary performance. In order to earn exemplary performance for this credit, the project should use GI and LID practices to capture and treat water from 50% of the impervious surfaces for the 95th percentile storm event. Please refer to your study notes to understand the related credits and reference standards for this credit. The next credit we will look at is Heat Island Reduction. This credit applies to all project types and is worth 2 points. What exactly is the heat island effect? A heat island is defined as a dark, non-reflective surface used for parking, roads, roofs, walkways, and other hardscapes that absorb the sun's warmth and radiate heat, creating a heat island. Urban areas can have a temperature of 1.8 degrees to 5.4 degrees Fahrenheit, or 1 degree to 3 degrees Celsius, warmer than the surrounding suburban and undeveloped areas, and as much as 22 degrees Fahrenheit or 12 degrees Celsius warmer in the evenings. These heat islands may contribute to regional average warming trends. Additionally, heat islands increase cooling loads in the summer, necessitating longer, more powerful air conditioners that use more electricity and in turn increase cooling costs, producing more greenhouse gases and generating pollution. This credit encourages project teams to adopt a variety of strategies, including reducing hardscape and incorporating the High Solar Reflective Index, or SRI, or high solar reflective materials such as vegetation and shaded parking, which minimizes a project's overall contribution to heat island effects. There are both establishment and performance requirements for this credit. Projects have 4 options from which to choose in order to earn this credit. Option 1 is for projects with compliant at-grade, or non-roof, strategies and no roof treatments or covered parking. Option 2 is for projects with compliant roofs but without compliant at-grade or non-roof strategies or covered parking. Option 3 is for projects with compliant roofs and at-grade non-roof systems but no covered parking. And Option 4 is for projects with only covered or underground parking. Projects should incorporate strategies for each option to meet establishment requirements and implement a maintenance program to meet the performance requirements. Let's take a look at Option 1, which applies to non-roof surfaces. Projects should use any combination of strategies for a minimum of 50% of the site paving. Here is a list of strategies. Install vegetated planters and use the existing plant material, or install plants that provide shade over paving areas, such as playgrounds, on the site within 10 years of planting. Note that plans must be in place at the issuance of the occupancy permit and cannot include artificial turf. Projects may also shade with structures covered by energy-generating systems, such as solar thermal collectors, photovoltaics, and wind turbines. Architectural devices or structures that have a 3-year age solar reflectance value of at least 0.28 may also be used for shading. Using paving materials with a 3-year age solar reflectance value of at least 0.28 will also help meet the credit requirements. If 3-year aged value information is not available, use materials with an initial SR of at least 0.33 at installation. This applies to architectural devices and paving materials. Please memorize these values as they are important. Projects may also use an open grid paving system with at least 50% unbound. The steps for implementation for Option 1 are listed here. The performance requirements for Option 1 are to implement a maintenance program that ensures all high reflectance paving surfaces are cleaned at least every 3 years to maintain good reflectance. This is a possible question. Now let's take a look at the Option 2 requirements. Projects may use roofing materials with either an SRI equal to or greater than the values in Table 1 for a minimum of 75% of the roof area, or a vegetated roof for a minimum of 50% of the roof area, or both. If using both high reflectance and vegetated roof surfaces, meet the following criterion using the formula shown here. Please memorize this formula, as questions may appear based on the formula. Alternatively, an SRI and SR weighted average approach may be used to calculate compliance. Here are the steps to implement Option 2. They are very similar to Option 1. Remember, there are performance requirements for Option 2 as well. That is to implement a maintenance program that ensures all high reflectance roof surfaces are cleaned at least every 3 years to maintain good reflectance, and all vegetated roofs are maintained for plant health and good structural condition. Option 3 is a combination that addresses non-roof and roof area. This project should meet the criterion per the formula listed here, which determines the combined compliance of roof and non-roof measures for the whole project. Projects can use any combination of the strategies we discussed under Option 1 and 2 to meet Option 3 requirements, such as shade from plants or trees, green roofs or vegetated roofs, or high reflectance roofs. The performance requirement here is a combination of Option 1 and Option 2. That is, to implement a maintenance program that ensures all high reflectance surfaces are cleaned at least every 3 years to maintain good reflectance, and all vegetated roofs are maintained for plant health and good structural condition. And finally, for Option 4, the establishment requirement is to place at least 50% of parking spaces under cover. Any roof used to shade or cover parking must have a 3-year aged SRI of at least 32. If 3-year aged value information is not available, use materials with an initial SRI of at least 39 at installation. Roofs may also be vegetated or be covered by energy generating systems such as solar thermal collectors, photovoltaics, and wind turbines. The performance requirement to implement this credit is a maintenance program that ensures all SRI surfaces are cleaned at least every 3 years to maintain good reflectance, and all vegetated roofs are maintained for plant health and good structural condition. To summarize this credit, project teams should identify parking, hardscape, and roof area. The team should then identify areas of existing and planned heat island mitigation measures. Determine which option the project will pursue. Projects may earn points for only one option, but are encouraged to incorporate as many heat island reduction strategies as possible. Projects may incorporate additional mitigation strategies as required to meet the credit compliance for establishment as listed on this slide. Finally, the team should create and implement a maintenance program. This credit is eligible for exemplary performance for all options. I recommend understanding each and memorizing their thresholds. Here are the exemplary performance opportunities for each option. Option 1. Install SR-compliant materials or open grid paving, or provide shading within 10 years for at least 95% of non-roof impervious surfaces. Option 2. Install a vegetated roof system for at least 95% of the project's roof area, excluding any mechanical equipment, photovoltaic panels, and skylights. Option 3. Achieve exemplary performance for both Option 1 and Option 2. Install SR-compliant materials and open grid paving, or provide shading within 10 years for at least 95% of non-roof impervious surfaces, and install a vegetated roof system for at least 95% of the project's roof area, excluding any mechanical equipment, photovoltaic panels, and skylights. Option 4. Locate at least 95% of parking under cover. The key items to remember here are 95% and 10 years. Listed here are the documentation requirements. Notice that the manufacturer's documentation and maintenance program apply to all options. Parking space calculations are only required for Option 4, as that is the only option that addresses covered parking spaces. Our next credit is Light Pollution Reduction. This credit applies to all project types and is worth 1 point. Artificial exterior lighting not only provides us safety and comfort, but it enables us to productively use more hours of the day. If done correctly, exterior lighting offers safety, security, building identification, aesthetics, and a way of finding where we're going. However, poor lighting design causes light pollution. This credit's intent is to increase night sky access, improve nighttime visibility, and reduce the consequences of development for wildlife and people. There are 2 options for this credit. Option 1 is appropriate if most of the existing fixtures are shielded already, or if the project team does not have the light measurement tool required for Option 2. Option 2 is for projects that have little lighting or have unshielded fixtures that do not spill over the boundary. Option 2 is about perimeter measurements. Projects should measure the night illumination levels at regularly spaced points on the project boundary, taking the measurements with the building's exterior and site lights both on and off. At least 8 measurements are required, at a maximum spacing of 100 feet or 30 meters apart. The illumination level measured with the lights on must be no more than 20% above the level measured with the lights off. There are no performance requirements for this credit. Option 1 is to shield all exterior fixtures where the sum of the mean lamp lumens for that fixture exceeds 2,500, such that the installed fixtures do not directly emit any light at a vertical angle more than 90 degrees from straight down. The first step to implement Option 1 is to identify all luminaires on the project site that use lamps whose sum for mean lamp lumens exceeds 2,500. All such luminaires must comply with the credit requirements. The second step is to determine whether the luminaire identified in Step 1 already met the shielding requirements. Existing luminaires are compliant if they do not directly emit any light at a vertical angle more than 90 degrees from straight down. Compliance with the shielding requirement can be confirmed via manufacturer's technical data sheets. If this information is not available, photographs of the luminaires can be used. Step 3 is to address non-compliant luminaires. Project teams should investigate options to retrofit or replace non-compliant existing site lighting to meet the credit requirements. Shielding to retrofit existing non-compliant luminaires may be available from the manufacturer or may need to be custom designed to work with the luminaire. As an alternative to shielding retrofits, change out the lamps. Non-compliant luminaires whose sum for mean lamp lumens is 2,500 or less meet the credit requirements. Under Option 2, projects should measure the night illumination levels at regularly spaced points on the project boundary, taking the measurements with the building's exterior and site lights both on and off. At least 8 measurements are required, at a maximum spacing of 100 feet or 30 meters apart. The illumination level measured with the lights on must not be more than 20% above the level measured with the lights off. Measurements may be taken on the same date, either after civil twilight in the evening or before civil twilight in the morning. This could be done with any light meter capable of measuring illumination at ground level. Illumination measurements with lights off and lights on should be taken. Compare the lights off and lights on illumination levels at each measurement point along the project boundary. To meet the credit requirements, at each measurement point, the lights on illumination must be no more than 20% above the lights off illumination. Listed here are the documentation requirements. Option 1 requires documentation on fixture schedule and luminaire shielding information, while Option 2 requires documentation on site plan with measurement points and illumination measurements. This credit is not eligible for exemplary performance. The last credit we will discuss is joint use of facilities and is applicable only for schools. A joint use agreement encourages community organizations and businesses to share existing amenity spaces. Doing so brings social benefits to the local community, and it may also reduce the need for new development, thereby preserving previously undeveloped land and avoiding the financial cost and environmental consequences of new construction. Local communities benefit most when multiple organizations share the cost of constructing, operating, and maintaining a facility. Joint use agreements allow buildings and sites that would typically go unused after normal business or operating hours to offer to host community programs, thereby maximizing the useful life of the building. In addition, communities may enjoy new or more convenient services. School projects have 3 options from which to choose for this credit. Option 1. Make building space open to the general public, worth 1 point. In collaboration with the school authorities, the team should ensure that at least 3 of the following types of spaces in the school are accessible to and available for shared use by the general public: the auditorium, gymnasium, cafeteria, 1 or more of the classrooms, playing fields and stadiums, and joint parking. In addition, projects should also provide access to the toilets in the joint use areas after normal school hours. Project teams should identify and allocate shared spaces, as well as establish terms and conditions. Option 2 is to contract with specific organizations to share the building space, worth 1 point. In collaboration with the school authorities, contract with community or other organizations to provide at least 2 types of dedicated use spaces in the building, such as the following: commercial office, health clinic, community service centers provided by state or local offices, police office, library or media center, parking lot, and 1 or more commercial businesses. Provide access to toilets in the joint use areas after normal school hours. Option 3 is to use shared space owned by other organizations, worth 1 point. In collaboration with the school authorities, ensure that at least 2 of the following 6 types of spaces that are owned by other organizations or agencies are accessible to students: the auditorium, gymnasium, cafeteria, 1 or more classrooms, swimming pool, and playing fields and stadiums. Provide direct pedestrian access to these spaces from the school. In addition, provide signed joint use agreements with other organizations or agencies that stipulate how these spaces will be shared. The example image here shows the project Move the Library for enhanced use by community members. This highlights the elements within a school facility that meet the requirements for the credit. Listed here are the documentation requirements for this credit. Okay, now it's time for a quick review. This is just a sample. You should still take the module quizzes loaded in your on-demand account after reviewing the section content for each meeting or module. We have approximately 40+ questions with answer explanations. Even if you answer a question correctly, I would recommend you look at the explanation, which includes an analysis of other answer choices, other scenarios, and tips. A project in Seattle with a 30,000 square foot total site area is planning to earn the credit under site development for on-site restoration. What is the minimum amount of native and adaptive vegetation that the site should have in place to promote biodiversity? The correct answer is 5,000 square feet. Some of you may have thought it was 6,000 square feet. The required area for vegetation is 20% of the site area, including the footprint, which in this case would be 20% of 30,000, which equals 6,000 square feet. However, the question asked the minimum amount of native or adaptive vegetation. Remember, option 1 is for projects with large, contiguous parcels of land. Projects should determine the total site area that must be native or adaptive vegetation using the 20% of total site area formula. If the currently vegetated area of the site exceeds the required area threshold, which is 5,000 square feet, and meets the credit requirements for native and adaptive vegetation, no additional restoration is necessary beyond the maintenance of the area. Note that the 5,000 square feet of area must have native and adaptive vegetation. If the project were to go for exemplary performance, then it should double the 20% restoration requirement to 40%. If the total area available for vegetation is less than the required minimum, the project is not eligible for option 1 and must pursue option 2 to earn this credit, which is financial support. Also note that project teams that pursue option 1 may also support conservation financially through option 2, but can earn credit for only one of these options. This could be a possible question. The total site area for a retail project is 45,000 square feet. How much should be the minimum financial contribution to earn SS Credit 1 Site Development? The answer is $225. The total site area times 0.5 cents will give you $225. Had the question been asking about exemplary performance, the answer would have been doubled to $450. A school project is planning to earn SS Credit Rainwater Management. What is the maximum number of points that the school can earn under this credit? The answer is 2 points. Remember, school projects only earn 2 points for this credit, whereas other project types can earn 3. What is the maximum number of points that a retail project can earn under the credit Joint Use of Facilities? The correct answer is none. The credit Joint Use of Facilities applies only to schools. Within how many days of inspection should the maintenance, repairs, and stabilization be done under SS Credit Rainwater Management? The answer is 60 days. Projects should document the annual inspections, including identification of areas of erosion and maintenance needs and repairs. In addition, the project should also perform necessary maintenance, repairs, or stabilization within 60 days of inspection as part of the performance requirements for the credit Rainwater Management. A project located in downtown Atlanta has a total site area of 45,000 square feet. The site has 5,000 square feet of impervious area. How much water must be captured and tested using GI and LEED practices in order to earn exemplary performance under SS Credit Rainwater Management? The answer is 2,500. The credit requirement is to use low-impact development, or LID, practices to capture and treat water from 25% of the impervious surfaces. In order to earn exemplary performance, the project would need to double that to 50% of impervious areas. In this case, it's 50% of 5,000 square feet. How often should the high reflectance roof surface be cleaned for option 2 under the Heat Island Reduction Credit? The answer is at least once every 3 years. This, again, is part of the performance requirements. The illumination level measured with the lights on must not be more than what % above the level measured with the lights off for light pollution reduction credit? The answer is 20%. The project is planning to earn light pollution reduction credit using perimeter measurement options. How many measurements are required and with how much spacing between them? The correct answer is 8 measurements and 100-foot spacing. We did discuss this under the credit requirements. What topics should the Site Improvement Plan include in order to attain the SS credit Site Improvement Plan? Please choose 3. The correct answers are hydrology, vegetation, and soils. We discussed this under the credit requirements. Credit synergies or related credits are an important element of the LEED exam. Please refer to the related credit section in your study notes. Instead of simply memorizing them, try to find the connections and understand how they relate to one another. It is best to review them after completing each module and again after completing all of the modules. You can see a few synergistic credits that we discussed today here on the slide, such as the Prereq Site Management Policy and the Credit Site Management Plan. As we discussed earlier, the O&M rating system addresses 6 LEED project types or space types: existing buildings, schools, retail, data centers, hospitality, and warehouses and distribution centers. As a LEED AP O&M candidate, you will be tested for your knowledge in the LEED requirements, resources, processes, application, and certification process for all of the above-mentioned building types. You do not need to memorize every credit. Instead, memorize the credits that are different. For example, a credit that has additional requirements for a project adaptation, a credit that is worth more than 1 point, or a credit that is eligible for exemplary performance. We are nearing the end of Module 4. Here is a summary for all of the credits that fall under the Sustainable Sites credit category. This table could be used to identify the exemplary credits and also design and construction credits. As you can see, there are 4 credits under Sustainable Sites that would qualify for exemplary performance: Site Development, Protect or Restore Habitat, Rainwater Management, Heat Island Reduction, and Places of Respite. In order for you to easily memorize the exemplary performance credits and their thresholds or options, we have uploaded memory charts to your on-demand account. Please print and use them to help you study. That concludes our discussion on sustainable sites. Let's go over a few key points. We analyzed establishment and performance requirements for various credits. The initial performance period is the most recent period of operations preceding the certification application. It must be at least 3 months, but no more than 24 months, except as noted in the credit requirements. Sustainable Sites offers an existing building project long-term improvement opportunity for LEED recertification. Projects must recertify within 5 years of the previous certification and are eligible as often as every 12 months. The recertification performance period extends from the date of the previous certification to the date of the recertification application. So here's our project. It is registered under the O&M rating system for LEED version 4. This is an existing building project that is considering some minor additions. Here's a quick self-evaluation exercise. Now that we have looked at the credits under SS, let's see what we can do with our project in respect to sustainable sites. You can see many strategies marked on our project image. Identify the credits under SS and LT that will have a positive effect by implementing these strategies. Come back to this exercise after completing all of the modules and try to identify credits under SS and other credit categories that will positively affect the project by implementing these credits. This exercise will assist you in understanding and mastering credit synergies. Once again, thank you for joining us for our LEED exam prep program. We hope you enjoyed the session. Please make sure that you rate this presentation on the GBRI website so that we know how much you enjoyed the course.
Hello everyone, and thank you again for joining our LEED O&M exam prep program. My name is Bob McCoy, and I will be presenting this module. Before we get started on water efficiency, I hope you were able to read and familiarize yourself with the key terms under water efficiency. If you haven't already, please do so later. The study notes we have provided are designed to complement the online modules. Sometimes you'll find more information in study notes on certain topics, including more examples, calculations, and so on. I would recommend you use these self-paced modules and the study notes hand in hand. Also, use of our other tools such as flashcards, memory charts, audio files, and more. Here you can see the topics we will cover for each meeting. When watching the content on demand, make sure you watch the 7 modules that represent the topics listed here. Here are the learning objectives for Water Efficiency module. By the end of this module, you will be able to identify the intent, requirements, and strategies for success with water efficiency credits, and also recognize ways to reduce water use inside and outside the building. You'll also learn to implement water metering to support better water management. You will also learn about credits that qualify for exemplary performance and recognize synergies between multiple credits. In addition, we will also look at credit compliance for projects outside the United States when applicable. There will be a total of 13 questions for the LEED exam from the Water Efficiency Knowledge domain representing the topics listed here: outdoor water use reduction, indoor water use reduction, and water performance management. We will explore each topic and LEED-related credits and prerequisites. The Water Efficiency WE section addresses water holistically, looking at indoor use, outdoor use, specialized uses, and metering. The section is based on an efficiency-first approach to water conservation. Projects have to look at historic water use, establish a baseline before incorporating water use reduction strategies such as efficient fixtures, non-potable and alternative sources of water, and so on. Establishing a baseline allows you to measure your actual performance goals. You'll hear the term baseline again when we discuss energy credits. There are 2 prerequisites under water efficiency credit category: indoor water use reduction and building level metering. The indoor water use prerequisite requires the projects to establish a baseline, thereby marking a certain level of efficiency across all fixtures. The prerequisite, building level water metering, allows the buildings to understand and measure the biggest end uses. You cannot manage something if you cannot measure it, as the saying goes. Metering allows you to understand how much water your building is using and where those gallons are going. Both prerequisites have a related credit. When discussing these prerequisites, we shall also look at the associated credits at the same time. This will help you for the exam as well to understand and remember requirements, analyze strategies, and apply them to projects. Let's look at the first prerequisite. Since there is also an associated credit, it makes more sense to look at them one after the other, or as a pair. The intent of this prereq, as well as the credit, is to reduce indoor water consumption. There are 2 options for the prereq as well as the credit. The prerequisite requires projects to use water below 120 to 150% of the current code if option 1 is selected, or maintain current water use levels if metered. That's option 2. If the project pursues the credit, then it should demonstrate 10 to 30% reduction from the prerequisite level under option 1, or up to 20% improvement for metered option, which is option 2. We will look at these options closely. Option 1 is calculated water use, where you calculate the water use, and option 2 is metered water use, where you use meters to measure water use. In both cases, you have to establish a baseline. Under option 1, you calculate the baseline. The baseline is the projection assuming code-compliant fixtures and fittings. The code here is UPC, or Uniform Plumbing Code, or IPC, International Plumbing Code. Under option 2, you measure the baseline using meters. The baseline is 1 year of data metered of fixtures and fittings. During the establishment period, the team should select the appropriate option based on preferences and water meter data availability requirements. Option 1 is for projects that do not separately meter at least 80% of fixtures as a percentage of total fixture count, or cannot isolate fixtures by subtracting all other building water systems based on sub-meter data. Option 2 is for projects that separately meter at least 80% of the fixtures as a percentage of total fixture count, or can isolate fixtures by subtracting all other building water systems based on sub-meter data. Remember the 80% criteria. As we noted in Module 1, LEED O&M rating system includes establishment and performance requirements for credits. For the prerequisite, we have both establishment as well as performance components. Let's look at option 1 requirements in detail. For the indoor plumbing fixtures and fittings listed in Table 1, the project has to reduce water consumption to or below the baseline. As I mentioned earlier, the baseline is calculated assuming 100% of the building's indoor plumbing fixtures and fittings meet the flush and flow rates per the code listed in Table 1, as shown here on the screen. As you can see from the table, the fixture of fitting addressed by the Prereq and credit only include toilets, urinals, lavatories, kitchen faucets, and shower heads. You don't have to memorize all the numbers on the table. I would recommend memorizing the flow rate of toilet and urinal, 1.6 gallons per flush and 1 gallon per flush. That's not hard, right? The year of building's occupancy is also factored in when calculating the baseline. For a building with a certificate of occupancy dated 1995 or later, the baseline is 120% of water use that would result if all fixtures met the code requirements in the table listed here. For a building with a certificate of occupancy dated before 1995, the baseline is 150% of the water use that would result if all fixtures met the code of requirements in the same table. Let's say an existing building pursuing LEED certification consumes 100 gallons for water for its fixtures and fittings. Assuming the flow rates per table, then the baseline would be 150% or 150 gallons if the building's certificate of occupancy dated before 1995, and 120% or 120 gallons if the building certificate of occupancy dated after 1995. Continuing with the establishment requirements for the Prereq. Once the project team determines the baseline use, then the project has to inspect all existing fittings or fixtures to ensure they are operating properly. Make any repairs needed to bring all fixtures into working order or permanently turn off water supply to non-functional units. The project then has to implement a fixture and fitting replacement and retrofit policy specifying that all newly installed toilets, urinals, lavatory faucets, and shower heads that are eligible for labeling be WaterSense labeled, or a local equivalent for projects outside the United States. Now to meet the performance component of the Prereq. The project should confirm that calculations are up to date for building water use and demonstrate that all applicable purchases made during the performance period meet the requirements of the fixture and fitting replacement and retrofit policy. Now that we know the requirements, let's look at how to implement Option 1. Step 1 is to determine the baseline. Projects should use the USGBC Indoor Water Use Calculator to determine baseline and the design or installed case water use. For buildings built before 1995 but renovated after initial occupancy in 1995 or later, projects should use Equation 1 to determine the baseline multiplier, a value between 120 to 150%. This could be a possible question. The next step is to gather information for the calculator. On the screen, I have included a screenshot of the calculator. The team should compile cut sheets or prepare plumbing fixture schedules with manufacturer's data that indicate its flush or flow rate. The team should collect fixture model, flush or flow rate, percentage of occupants with access to the fixture. This information is needed to use for the calculator. Also, the project team should classify fixtures as public or private. Lavatory faucets must be classified as public or private. The Uniform Plumbing Code, International Plumbing Code, and the National Standard Plumbing Code each define private as those fixtures in residences, hotels or motel guest rooms, and private rooms in hospitals. All other applications are deemed to be public. This could be a possible question. A separate calculation to accommodate visitors is not necessary because the calculator automatically assigns them a lower daily usage rate. For example, it assumes that visitors do not use kitchen faucets. Gender ratio is another important aspect. The default gender mix is half male and half female. Assumptions that differ from the default must be supported by a narrative and supporting data. A possible question. Modifications to the 50-50 ratio must be shown to apply for the life of the building. Acceptable special circumstances include projects specifically designed for an alternative gender ratio. For example, a single-gender educational facility. Such projects must show that flush and flow fixtures have been distributed to account for the modified ratio. Gender ratio affects water usage only when urinals are installed. If the project does not include urinals, a 50-50 or 0 to 100 male-female ratio should yield the same usage results. Days of operation. The default number of days of operation per year is 365. If the project is in use for only a portion of the year or closes on specific days, the days of operation can be reduced. The same number of days of operation must be applied to both the baseline and the design cases. A possible question. Projects should also ensure that the number of days of use is consistent with the building's operating schedule and prepare supporting documentation. For K-12 schools that close on weekends, holidays, and for 8 weeks of school vacation, project teams should assume 195 days of operation. The total for all fixtures of each type must total 100% of occupants for standard fixture types. The final step is to complete the calculations for the design case or installed flush and flow fixtures. The usage-based calculation for the project is the difference between the calculated design case and a baseline case. Listed on the screen is a sample table that shows the flow rates of UPC-compliant fixtures for baseline and WaterSense labeled fixtures for design or installed case. The Prereq requires projects to use water below 120 to 150% of the current code or maintain current water use levels if metered. If the project pursues the credit, then it should demonstrate 10 to 30% reduction from the Prereq level under Option 1. The calculator determines usage based on Equation 1. Daily water use for each fixture type equals fixture flush or flow rate times duration of use times number of user times uses per person per day. Occupants' estimated use is determined by counting full-time equivalent and transient occupants and applying appropriate fixture use rates to each. The calculator estimates the percentage reduction of potable water use compared with the baseline using this equation. Note that the duration of use, number of users, and uses per person per day must be the same in both the baseline and the design cases. This is a possible question. Use Equation 2 to perform the conversion. Gallons per cycle times 60 seconds divided by cycle duration in seconds. For your exam, I would recommend memorizing both of these equations. Appliances and equipment that use water or materials intended for human consumption may be excluded. For example, bread and produce misters, soda machines, coffee-making machines, and fixtures used to fill sinks for washing produce are excluded. Fixtures whose flow rates are regulated by health codes may be excluded from the calculation. For example, regulated medical equipment is considered a process water user and is excluded from fixture calculations. Process water sinks are excluded from the fixture water use reduction calculations, such as janitor sinks, laboratory sinks regulated for medical or industrial purposes, commercial kitchen or food service sinks and prep sinks, janitor closet sinks, medication room sinks, and utility room sinks. Now that we have mastered Option 1, let's look at Option 2 requirements. As noted earlier, Option 2 is for projects that separately meter at least 80% of fixtures as a percentage of total fixture count, or can isolate fixtures by subtracting all other building water systems based on sub-meter data. The establishment component requires projects to meter fixtures and fittings and record metered data for 1 year to establish a water use baseline. The performance component requires projects to have at least 80% of fixtures and fittings metered and show that the water use baseline has been maintained. Here are the implementation steps for Option 2. The first is to determine baseline use for 1 year, based on the building's water meter data. If submeters do not exist or the project does not have 12 months of data, the project team may choose to install submeters for 80% of fixtures or begin recording data. This is a possible question. Alternative water sources can be separately metered or metered along with fixtures' potable water use, provided the metering is done uniformly for both the baseline and the performance periods. The next step is to analyze current practices and design to determine where improvements may be made. This may include older fixtures with especially high flush and flow rates, fixtures in high-use areas, and fixtures with known maintenance issues. Project should determine which repairs or retrofits would yield the most water savings. Making improvements is next by installing new fittings or fixtures, or using alternative water sources to increase the percentage reduction from baseline. And the next is to measure water usage during performance period and calculating percentage improvements using performance period data. Here are some adaptation-specific requirements for retail, hospitality, and schools only. These projects should have in place a process and appliance The policy must cover at least those products purchased within the building and site management's control. Note that appliances are required to meet the Energy Star or CEE Tier 3 standards to meet the performance requirement of the prerequisite for appliances. Projects should demonstrate that appliances purchased and installed within the building meet the requirements listed in Table 2. Note that appliances not listed are not subject to any additional requirements. This is a possible question. Now that we have looked at the prerequisite, let's analyze how a project may earn the related credit Indoor Water Use Reduction. All projects, except data centers, can earn up to 5 points by considering additional water use reduction through efficient features and use of non-potable water. The table here shows the point distribution for reducing calculated water use beyond the prerequisite level using option 1. As you can see, all projects except data centers can earn up to 5 points for water use reduction, with points starting at 10% and an additional point for every 5% until a maximum of 30% water use reduction. You do not have to simply memorize the whole table. Remember, 10%, which is the starting threshold, the 5% increment, and maximum reduction, which is 30%. The table below shows point distribution for reducing metered water use beyond the prerequisite using option 2, which starts with 1 point for less than 5% reduction, and so on until 20% reduction. One exemplary performance point is available for achieving either a minimum reduction of 35% using option 1 or a minimum reduction of 25% using option 2. Make sure you remember this. Here is how we calculate the water savings. The usage-based calculation for the project is the difference between the calculated design case and a baseline case. The percentage is determined by dividing the design case reduction by the baseline reduction. The calculator estimates the percentage reduction of potable water use compared with the baseline using the equation you see on the screen. All right. Now that we know all the requirements for Prereq and credit indoor water reduction, let's brainstorm strategies for our LEED O&M project in Iowa. So, what are some strategies that you would propose to reduce indoor water use consumption? Just like the previous exercise, you may enter your ideas. If you're watching this session on demand, please note down your ideas on a piece of paper. Here, I am listing some broad categories. Keep entering your ideas. So now let's expand my list. Efficient faucets. They can help increase a building's water efficiency. There are also the reduced metered valve faucets that shut off after a designated amount of water is dispensed from the tap. This prevents user errors that can affect a building's water efficiency, such as someone who does not close the tap all the way and leaves the faucet to drip overnight. Self-closing faucets with sensors are similar, but these faucets shut off after a designated time rather than a certain amount of water. Infrared faucets, or hands-free faucets, start and stop dispensing water when it detects or does not detect motion or objects. Any of these options are also good for reducing spread of germs and preventing excess mess. Low-flow aerator faucets use specialized airflow regulators to mix water and air to decrease water flow consumption, but increase water flow pressure. You can also find WaterSense labeled faucets that will list their efficiency rates and features. Low-flow shower heads are a great way to reduce water consumption, and a variety of options are available. Atomizer shower heads use small amounts of water in bursts to deliver a liquid mist spray. Projects should look for the EPA WaterSense label when incorporating efficient water fixtures whenever applicable. Apart from using large volumes of water, toilets and urinals also contribute to additional operation and maintenance costs, including sewage costs. Older toilets typically use 3.5 to 7 gallons per flush. Designing and installing a low-flow toilet not only reduces water use consumption, but also reduces sewage volume. Though some low-flow toilets give problems, today's low-flow toilets are much more effective and efficient, and their parts are more durable and replaceable. There are also ultra-low-flow toilets, or ULFTs. Ultra-low-flow toilets usually use one of two methods to clear waste: gravity or pressure-assisted. Though pressure-assisted toilets are efficient, they do make a bit of noise compared to traditional gravity ones. Plus, they are more expensive than gravity models. Another option is HET, or high-efficiency toilets. Most of the HETs consume 1.28 gallons per flush, which means they use about 20% less water than the average low-flow toilets. One type of high-efficiency toilet is the dual flush. You may have seen these types of toilets in hotels. Solid waste is cleared with 1.6 gallons of water per flush, and liquid waste is flushed away with only 0.8 gallons. Again, projects should look for the EPA WaterSense label when incorporating efficient water fixtures such as HETs. For your exam, you don't have to memorize all flow rates, but should be familiar with the strategies in general, as they will appear in questions and answer choices. Now that we looked at water efficiency measures, let's explore alternative sources. Here is a list, many of which you all entered. You should try to remember this list. Alternatives to potable water include municipally supplied reclaimed water or purple pipe water, gray water, rainwater, storm water, condensate, foundation dewatering water, used process water, and reverse osmosis reject water. For fixtures that require the WaterSense label in countries where the label is unavailable, look up acceptable WaterSense substitutes at usgbc.org. Projects in unlisted countries must comply with the 20% below baseline requirement, but have no additional performance requirements. For appliances that require the ENERGY STAR label, a project outside of the United States may install products that are not labeled under the ENERGY STAR program if they meet ENERGY STAR product specifications available on the ENERGY STAR website. All products must meet the standards of the current version of ENERGY STAR as of the date of their purchase. For appliances that require the Consortium for Energy Efficiency, or CEE label, a project outside the United States may purchase products that have not been qualified or labeled by CEE if they meet the CEE product criteria for efficiency. Listed here are the related credits for both the Prereq as well as the credit. As you can see, the metering Prereq as well as the credit are related to this prerequisite. Metering of potable water usage will allow facilities management staff to monitor changes in water usage as efficiency measures are implemented. Also listed here are the documentation requirements for the prerequisite as well as the credit. The Prereq requires projects to submit cut sheets, indoor water calculator, and purchasing policy related to fixtures and fittings. The credit, on the other hand, requires projects to submit meter data, indoor water use calculator, and alternative water sources. Now let's look at our next prerequisite, building level water metering. This prereq allows buildings to understand and measure the biggest end uses. As the saying goes, you cannot manage something if you cannot measure it. Metering allows you to understand how much water your building is using and where those gallons are going. In order to ensure that water consumption is optimized at a building level, which includes both the project building and grounds, monitoring and measurement strategies should be implemented and water meters be installed. There are establishment as well as performance requirements for the prereq. Under establishment, projects should have permanently installed water meters that measure the total potable water use for the building and associated grounds. Metering of any gray or reclaimed water supplied to the building is encouraged but not required. Responsible parties for this prereq include the owner, maintenance staff, facility manager, building manager, and the LEED AP. Let's look at how to implement the establishment portion of the prereq. Project team should determine all end uses of potable water in the project building and on the grounds. These could include plumbing fixtures, cooling towers, and evaporative condensers, laundering, dishwashing, indoor and outdoor water features, irrigation, exterior cleaning, and manufacturing processes. All potable water sources must be metered so that operations staff can track water consumption over time. Examples of potable water sources that must be metered include public water supply, on-site well, on-site potable water treatment system. If the project is not served by a public water supply, or if the project uses multiple sources of potable water, 2 or more meters may be required. A single meter installed downstream of multiple potable water supply systems may be used if it is upstream of all project water uses. If all water comes from a public water supply and the utility's water meter provides monthly consumption data, that system's meter meets the prerequisite requirements. The public water supplier restricts access to the meter or uses proprietary remote reporting technology, the project team may meet the prerequisite requirements by tracking water usage through monthly billing. To collect more frequent or accurate data, the team may elect to install a private meter downstream from the public water supply meter. Note, this is not a requirement, but a recommendation for the prerequisite. If rainwater, gray water, or municipally reclaimed water is used in the building, consider metering those volumes individually as well. Project should begin tracking water consumption during the performance period. Monthly tracking is part of the requirement. Although monthly tracking is required, weekly or daily readings provide quicker information about spikes in consumption and may help identify ways to capture additional savings. In order to meet the performance requirements of the prereq, project teams shall record meter data on a monthly basis and compile. Meter readings can be manual or automated. Commit to sharing with USGBC the resulting whole project water usage data for a 5-year period beginning on the date the project accepts LEED certification or typical occupancy, whichever comes first. This commitment must carry forward for 5 years or until the building changes ownership or leasee. Here I have listed the related credits. As you would expect, first and second related credits are water use reduction and water metering respectively. Energy prerequisite, building level energy metering, is the third related credit. Water meters may be tracked by a building automation system, or BAS, that also records energy consumption. Data sharing for both this and the related prerequisite can be achieved through Energy Star's Portfolio Manager. Meter declaration, sharing commitment with USGBC, and consumption data are the 3 submittal items for LEED documentation. Let's look at the associated credit water metering. The credit applies to all project adaptations and is worth up to 2 points. The intent here is to support management and identify opportunities for additional water savings by tracking water consumption. Metering water usage by subsystem helps facilities managers better gauge a building's water efficiency. Submetering the major building water systems provides a way to formulate independent system baselines, track usage against those baselines, isolate and identify potential sources of waste, and take corrective action. Just like the prerequisite, there are establishment as well as performance requirements for the credit. Under Establishment component, projects should establish permanently installed meters, 1 point for 2 water subsystems, 2 points for 4 or more water subsystems listed here. For irrigation, projects should meter water systems serving at least 80% of the irrigated landscape area. To calculate the percentage of irrigated landscape area, you should take the total metered irrigated landscape area and divide by the total irrigated landscape area. Note that landscape areas fully covered with xeriscaping or native vegetation that requires no routine irrigation may be excluded from the calculation. As for indoor plumbing fixtures and fittings, project should meter water systems serving at least 80% of the indoor plumbing fixtures and fittings listed in As for indoor plumbing fixtures and fittings, project should meter water systems serving at least 80% of the indoor plumbing fixtures and fittings listed in Prerequisite Indoor Water Use Reduction, either directly or by deducting all other measured water use from the measured total water consumption of the building and grounds. Cooling tower. Meter replacement water use of all cooling towers serving the facility. Domestic hot water. Meter water use of at least 80% of the installed domestic hot water heating capacity, including both tanks and on-demand heaters. For reclaimed water, project should meter reclaimed water regardless of rate. Note that. A reclaimed water system with a makeup water connection must also be metered so that the true reclaimed water component can be determined. For all other process water, projects should meter at least 80% of expected daily water consumption for process end uses, such as humidifiers, dishwashers, clothes washers, and pools. So the key number to remember here is 80%, and also the fact that reclaimed water, if used, should be metered. Now, for the performance requirements. All meters, including whole building meters, must be recorded at least weekly and used in a regular analysis of time trends. As you would recall, for the prerequisite, recording was only required once a month. For the credit, meters must be calibrated within the manufacturer's recommended interval if the building owner, management organization, or tenant owns the meter. Meters owned by third parties, for example utilities or governments, are exempt. Projects shall also commit to sharing with USGBC the resulting water usage data for a 5-year period beginning on the date the project accepts LEED certification or typical occupancy, whichever comes first. Now, with respect to implementing this credit, the first step is to identify the ideal candidate systems for submetering. The project team shall identify all systems serving the project building and grounds. These subsystems may include irrigation, indoor plumbing fixtures, domestic hot water, process water, reclaimed water, and boiler water. Note that cooling tower submeters are addressed separately under WE Prerequisite Indoor Water Use Reduction. The team should consider those subsystems that consume the most water, are the most expensive to operate, or most closely align with the goals of the building management. A variety of factors will affect the decision. Project teams should consider not only the number, types, and sizes of meters, but also the effort required to take meter readings. The cost of a wet meter, a meter installed in the pipe, increases with pipe size. Many external clamp-on meters are adaptable to a range of pipe sizes. Clamp-on meters are more costly on small diameter pipes, but initial cost differences are reduced for larger pipes. The higher cost of a larger meter may be offset by reduced operations and maintenance costs if facility staff will be making manual readings. Automatic data logging also adds to initial cost, but it may be cost-effective if it reduces the effort of obtaining and recording readings. Here is the required calculation for the credit. If the project team is claiming credit for irrigation, indoor plumbing fixtures, domestic hot water, or other process water submeters, at least 80% of water distribution must be submetered. If 100% of the water used by a subsystem is metered, no calculation is necessary. Using the formula you see on the screen, project teams should determine how much of the total water system will be submetered by comparing the submetered portions with total landscape area, number of indoor fixtures, domestic water heating units, or process use quantities. Note that unirrigated landscape areas should not be included in either the numerator or denominator of this equation. There are more equations for indoor fixtures, domestic water heating systems, and process-type end uses. Just remember the right-hand side of the equation, 80%. That's the requirement to earn the credit. If the team is using reclaimed water for irrigation, 100% of this water must be submetered. The meter for reclaimed water may also be the same meter that is counted for irrigation, fixtures, or process water. If reclaimed water is used in multiple applications in the project, for example, irrigation, flux fixtures, or process water, then all reclaimed water must be metered. The team may report data from multiple submeters as applicable. The project team should choose a submeter type if no existing meters are present or if existing meters need replacing. Submeters may be manually read or connected to a building information system. The meters may be equipped with data logging capability independent of a building information system. If meters are to be read manually, project teams should consider digital indicators, which may reduce errors in recording. Wet meters will likely be the most cost-effective approach. However, clamp-on meters may be simpler to install. The team shall collect meter data for each subsystem at least weekly during the performance period and calibrate meters in accordance with the manufacturer's recommendation. Note that if the manufacturer does not recommend recalibration within 10 years of installation, the team should recalibrate or replace meters every 10 years. As for the documentation, project team should prepare a narrative describing the subsystems metered, including the location and model of each installed submeter as part of the documentation. In addition, weekly meter log, monthly and annual summaries of meter data is needed to be submitted. WE credits, indoor and outdoor water use reduction, are the related credits. All right, let's now get into the next credit, outdoor water use reduction. This credit is worth up to 2 points and is applicable for all project types. The intent of this credit is to reduce outdoor water consumption. Landscape irrigation practices consume large quantities of potable water, sometimes accounting for 30 to 70% of the water consumed in non-agricultural use. Good landscape design and use of native, adapted, and drought-tolerant plants can dramatically reduce and even eliminate the need for irrigation while better integrating the building site into its surroundings and attracting native wildlife. Native plants also tend to require less fertilizer and fewer chemical pesticides, which degrade water quality when carried away in stormwater runoff. Projects have three options to choose from to reduce outdoor water use. Non-vegetated surfaces, such as permeable or impermeable pavement, should be excluded from landscape area calculations. Note that athletic fields and playgrounds, if vegetated, and food gardens may be included or excluded at the project team's discretion. Each option is worth 2 points. Under Option 1, projects should show that the landscape does not require irrigation beyond a maximum 2-year plant establishment period. If landscape irrigation is not submetered, projects should use Option 2. Option 2 requires projects to use the EPA WaterSense Water Budget tool to calculate the landscape water requirement, or LWR. Projects should also install an irrigation meter. If an irrigation meter is installed, projects may choose Option 3. In this case, projects are required to establish a baseline using the annual average of at least 3 years of consecutive data out of the last 5 years. Points are earned for a reduction in outdoor water use over the most recent 12 months compared with the established baseline. Points for Option 2 and 3 are earned according to Table 1 shown here. Here are project stakeholders who play an active role for this credit. For your exam, you don't have to memorize this. The list is provided so that you are familiar with the team members. All projects are required to follow these steps to earn this credit, no matter which option they choose. Step 1 is to obtain precipitation and evapotranspiration data. Projects in the United States can use the WaterSense Water Budget tool, which automatically derives rainfall, and evapotranspiration from the project zip code. A screenshot of the tool is seen here. For projects outside the United States, gather average monthly precipitation data and evapotranspiration rates, or ETO, for the project area to determine the site's potential irrigation needs. This information may be collected through various government and academic sources. Once the precipitation data is gathered, next is to determine vegetated areas. The project team should indicate all areas on the project site that are or will be vegetated on a map. Note that hardscapes, whether pervious or impervious, or unvegetated softscapes such as mulched paths and playground areas should not be included. Vegetated playgrounds, athletic fields, food gardens, and urban agricultural areas may or may not be included at the team's discretion. The next step is to select plant types and coverage. This includes identifying plant types and coverage that will balance water use efficiency with the area's intended function. Once established, native and drought-tolerant plants generally require little to no irrigation. Project team shall reserve grass for playfields or other activities that require turf. Using turf for ground cover will make it very difficult to meet the credit thresholds. Next is to select the appropriate option for the project's irrigation needs. Option 1 is for projects that do not require irrigation based on the location and landscape design. Projects that have no landscape area automatically earn this credit. A possible question. Option 2 is for projects that require irrigation but do not have an irrigation meter installed or do not have meter data for at least 3 years. Another possible question. Option 3 is for projects that require irrigation, have an irrigation meter installed, and have meter data for at least 3 years. This is also the appropriate option for recertification of projects that have at least 12 months of water baseline tracking, followed by 12 months of performance data. Another possible question. Let's look at implementing option 1. Projects should develop the plant species and water requirement narrative. Describe the plantings and explain why they will not require irrigation beyond their specified establishment periods. Indicate why average rainfall will be sufficient. A landscaping plan showing native plants may be provided to confirm that irrigation will not be required, based on local rainfall and plants' water demands. In order to implement option 2, when no irrigation meter is installed, the first step is to reduce irrigation needs by altering design, which includes selecting plants that are appropriate for their intended uses, restoring or planting native species to replace areas requiring intensive irrigation. Step 2 is to consider alternative water sources, collected on-site or treated wastewater provided by a municipal agency to offset potable water for irrigation. The team should check local ordinances and laws, as some states do not allow using graywater reuse or harvesting rainwater. Step 3 is to consider smart irrigation controls for additional water savings. Once all that is done, the team should calculate landscape water budget using the WaterSense water budget tool. The team may resolve uncertainties about plants' water requirements by referring to local resources such as plant guides, the State Agricultural Extension Service, or nurseries to classify each plant as a low, medium, or high water user. Note that projects may not enter zero landscape water consumption for any landscaped area. If only part of the lot is irrigated, complete the calculation twice. Once for the irrigated section and again for the unirrigated area, and sum the results. This is a possible question. The next step is to calculate Adjusted Landscape Water Requirements, or LWR, using equations 1 and 2. The volume of water obtained from any alternative sources can be determined from historical data or, for municipally supplied treated wastewater, from utility bills. Count only irrigation controls whose smart sensor technology meets the WaterSense criteria. These controls result in an additional 15% reduction that project teams can take from the baseline. This is a possible question. For initial certification of a project that previously had no irrigation water meter, or a project lacking at least 3 years of irrigation data, the team must install a meter and begin tracking irrigation water use. For projects pursuing options 3, the first step is to establish irrigation water usage baseline by taking the annual average of at least 3 years of consecutive data from the past 5 years. The baseline must be established using data from years before the performance period. For future recertification, the original baseline can be used for 10 years. After 10 years, reset the baseline following the instructions above. The baseline content should be drawn from the immediate 5 years before the performance period year. The next step is to analyze current irrigation practices and landscape design to determine where improvements may be made. Consider plant species selection, planting density, and location of plants relative to sunlight, shade, water access, and topography. Once improvements are installed, measure the irrigation water usage during the entire performance period. For the most recent 12 months of the performance period, compare data with the baseline. This option requires a 12-month performance period. A possible question. Percentage improvement can be computed using the equation shown here. Here, you can see the documentation requirement for each option. Option 1 only has one documentation requirement, a narrative for plant species and water requirement. Option 2 requires a site plan, water budget report, and alternative water supply calculations. Option 3 requires alternative water supply calculations and irrigation meter report. If you understand the requirements for each option, it is easy to relate the required documentation. This credit applies to all project adaptation types and is worth up to 3 points. Only projects served by cooling towers or evaporative condensers are eligible for this credit. Cooling towers can account for large portions of a building's total water use. The intent of this credit is to conserve water used for cooling tower makeup while controlling microbes, corrosion, and scale in the condenser water system. To significantly reduce makeup water inputs, it is important to achieve target cycles of concentration. Cooling tower or evaporative condenser water efficiency is measured in the number of recirculation cycles before water must be removed by blowdown. Increasing the number of cycles can save thousands of gallons of potable water during a building's peak cooling periods. Chemically analyzing makeup water allows for calculation of optimal cycles. Cycles can also be increased by treating water to remove or sequester dissolved solids rather than relying only on blowdown and input of fresh water makeup. Let's look at the requirements. Under Establishment, for cooling towers and evaporative condensers, projects should conduct a potable water analysis within 5 years of submission for certification, measuring at least the 5 control parameters listed here. In addition, projects should calculate the number of cooling tower cycles by dividing the maximum allowed concentration level of each parameter by the actual concentration level of each parameter found in the potable makeup water. Limit cooling tower cycles to avoid exceeding maximum values for any of these parameters. The table listed here shows point distribution and criteria. Data center projects can earn only 3 points, whereas all other projects can earn up to 4 points under this credit. All projects, including data centers, could earn up to 2 points by achieving maximum number of cycles without exceeding any filtration levels or affecting operation of condenser water system, up to a maximum of 10 cycles. To earn 3 points for data centers and 4 points for other projects, demonstrate one of the following. Achieve a minimum of 10 cycles by increasing the level of treatment in condenser or makeup water, or meet the minimum number of cycles to earn 1 point and use a minimum 20% recycled non-potable water. There are no performance requirements for this credit. Listed here are the steps to implement this credit. The first step is to obtain water analysis. Whether the project uses 100% potable water or 100% non-potable water for cooling, the first step is to obtain a chemical analysis. The project should engage a water treatment professional to perform the analysis. Note that if a potable water analysis has already been completed, it must be no more than 5 years old. At a minimum, the analysis must measure the concentration parameters identified in the credit requirements. The next step is to calculate the number of cooling tower cycles by dividing the maximum allowed concentration level of each parameter by the actual concentration level of each parameter found in the potable makeup water. Limit cooling tower cycles to avoid exceeding maximum values for any of these parameters. Adjust the cooling tower or evaporative condenser settings for the maximum number of cycles without exceeding concentration levels or affecting condenser operation. Once the cycles of concentration is calculated, project should identify a limiting factor by identifying which concentration parameter has the fewest calculated cycles before it exceeds the maximum concentration. That parameter's number of cycles, the limiting factor, will determine the maximum number of cycles for the cooling tower or evaporative condenser. A possible question. The next step is to adjust the cooling tower or evaporative condenser settings for the maximum number of cycles without exceeding concentration levels or affecting condenser operation. For one additional point, projects may use further treatment, filtration, or non-potable water to increase the number of cycles. Evaluate whether greater potable water efficiency could be achieved by treating makeup water to reduce or sequester some of the dissolved solids. Non-potable water derived from the site can offset a portion of the potable water used for makeup. Note that acceptable sources should have relatively low levels of dissolved solids. Stormwater runoff from the ground surface or gray water may contain contaminants, including dissolved chlorides, that may need treatment. In contrast, air conditioning condensate and rainwater collected from building roofs have relatively low mineral content. Good non-potable water sources include the following: air conditioner condensate, rainwater, steam system condensate, food steamer discharge water, fire pump test water, ice machine condensate. Other factors to consider are ease of transport to the cooling tower and required volume of makeup water. The last step is to verify that the cooling tower or evaporative condenser settings are consistent with the number of cooling tower or evaporative condenser cycles. Projects should also prepare a narrative detailing the settings and other performance characteristics. Listed here are the documentation requirements for the credit, more or less in line with the steps that we just went through. That concludes all the credits and prereqs under water efficiency. Now, let's do a quick review. Which of the following should be excluded from outdoor water use calculations, landscape water budget, for an O&M project pursuing WE Credit outdoor water use reduction? Choose 3. The correct answers are A, B, and C. Watch the question here. The question specified should and not may. Projects should use the EPA water budget tool for vegetated areas only. Projects should not include hardscapes, whether pervious or impervious, or unvegetated softscapes such as mulched paths and playground areas. If the question had said may, then the following landscape types may be included or excluded from landscape calculations: vegetated playgrounds, athletic fields, food gardens, and urban agricultural areas. Another possible question. Which of the following must be submitted as documentation for projects pursuing WE Prerequisite building level water metering? Select 3. The correct answer is A, B, and C. The documentation requirements for WE Prereq building level water metering include 1. Meter declaration, and 2. Sharing commitment with US GBC and consumption data. Note that consumption data for the prerequisite is done on a monthly basis. Let's look at other answer choices. Those are documentation requirement for WE credit building water metering. A project in Austin, Texas is pursuing WE credit outdoor water use reduction by using option 2. No irrigation meter is installed. Which of the following measures may be used to reduce the project's landscape water requirement, LWR, by at least 30% from the calculated baseline for the site's peak watering month? Choose 3. The correct answer is C, D, and E. A project installs only irrigation controls whose smart sensor technology meets the WaterSense criteria. What additional percentage reduction these controls result in that project teams can take from the baseline? The correct answer is C, 15%. As noted earlier, projects should count only irrigation controls whose smart sensor technology meets the WaterSense criteria. These controls result in an additional 15% reduction that project teams can take from the baseline. Which of the following measures will help a data center project earn 3 points pursuing WE credit cooling tower water? Select 2. The correct answer is B and D. All projects, including data centers, could earn up to 2 points by achieving maximum number of cycles without exceeding any filtration levels or affecting operation of condenser water system, up to a maximum of 10 cycles. To earn 3 points for data centers and 4 points for other projects, demonstrate one of the following. Achieve a minimum of 10 cycles by increasing the level of treatment in condenser or makeup water, or meet the minimum number of cycles to earn 1 point and use a minimum 20% recycled non-potable water. All right, let's look at some credit synergies. We looked at some of the related credits when we went over the exam prep materials. As you saw, most of the credits under water efficiency are related to each other. Metering, for example, is related to all the credits under water efficiency. Metering of potable water usage will allow facilities management staff to monitor changes in water usage as efficiency measures are implemented, so that's indoor water use reduction. The same applies for outdoor water use. Subsystem meters to measure cooling tower or evaporative condenser makeup water can assist in water management and can help optimize cycles of concentration. There are sustainable sites credits such as Rainwater Management, Heat Island Effect Reduction, Site Management Plan, all related to water efficiency credits. Rainwater collected and treated for the credit may also contribute to the related water efficiency credit by reducing the potable water demand. The vegetation you choose for your landscape can influence the credits under sites and vice versa. After you complete the energy and atmosphere section, you will notice the connection between energy and water as well. This is mostly with sub-meters. Water meters may be tracked by a building automation system, or BAS, that also records energy consumption. Data sharing for both this and the related prerequisite under Energy and Atmosphere can be achieved through Energy Star's Portfolio Manager. Here is a list of strategies that could be applied to water portion of a LEED project. Here is a quick self-evaluation exercise. Try to identify the credit that gets affected by these strategies. Some of the strategies may affect multiple credits sometimes, even from other categories, such as water and energy. Revisit the same exercise after completing all modules. The WE category comprises three major components: indoor water, used by fixtures, appliances and processes, such as cooling, irrigation water, and water metering. Several kinds of documentation span these components depending on the project's specific water-saving strategies. I have listed the major documentation components. Site plans. Plans are used to document the location and size of vegetated areas, and the locations of meters and submeters. Within the building, floor plans show the location of fixtures, appliances, and process water equipment, as well as indoor submeters. The same documentation can be used in credits in the Sustainable Sites category. You can see the synergy here. Fixture cut sheets. Projects must document their fixtures, and appliances as applicable, using fixture cut sheets or manufacturer's literature. This documentation is used in the Indoor Water Use Reduction Prerequisite and credit. Alternative water sources. A project that includes gray water reuse, rainwater harvesting, municipally supplied wastewater, purple pipe water, or other reused sources is eligible to earn credit in WE Credit Outdoor Water Use Reduction, WE Credit Indoor Water Use Reduction, WE Credit Cooling Tower Water Use, and WE Credit Water Metering. But the team cannot apply the same water to multiple credits unless the water source has sufficient water volume to cover the demand of all the uses. For example, irrigation plus toilet flushing demand. Occupancy calculations. The Indoor Water Use Reduction Prerequisite and credit require projections based on occupancy usage. The Location and Transportation and Sustainable Sites categories also use project occupancy calculations. Review the occupancy section in Getting Started to understand how occupants are classified and counted. Also, see WE Prerequisite Indoor Water Use Reduction for additional guidance specific to the WE section. Metering and tracking. The WE credits have significant synergies between installing water meters and documenting savings. We have included a table that details the role of water meters in your study notes. Here are things to do before attending the next meeting or watching the next module on demand. First, refer to your roadmap that we prepared for you. Per your roadmap, you should revise the current modules, and then take the respective quizzes from your on-demand account. Identify gaps, if any, and revise the online modules or meetings as necessary. Make use of flashcards, examples in study notes and memory charts. Come prepared for next meeting or module, if watching on demand, by familiarizing yourself with the key terms related to the next module. Thank you again. This concludes Module 4. Just like for the other sections, I recommend watching this section again through your on-demand account. Revising the content again is key to memorizing important points. Please make sure that you rate this presentation on the GBRI website so we know how much you enjoyed the course. Also, GBRI can automatically report these hours for you to AIA if we have your AIA member numbers. If we have these numbers for you already, these hours will automatically be reported. If you have not given us your member numbers, please do so by clicking on the Auto Reporting Form link on this screen. Thanks again, and have a great day.